Good morning. What we're going to do is I'm going to go over some of the expected value stuff we did in class, just so you have a recording of me kind of talking about it in case you want to go back over it. So we'll start. So first question, we want to read and we want to able to turn this into a probability distribution. So a $20 bill, two $10 bills, three $5 bills, and four $1 bills are placed in a bag. If a bill is chosen at random, what's the expected value of the amount chosen? Okay, so it's the average, but we got to weight it based on how many are in there. So we have, 120, we have two 10s, we have three 5s, and we have four 1s. So we actually have 1 plus 2 plus 3 plus 4. We have 10 items in here. So the way we set it up is we want to put our outcomes in there. So our outcomes are going to be that you're going to win $20, or get a $20 bill, you're going to get a $10 bill, you're going to get a $5 bill, or you're going to get a $1 bill. The probabilities of those outcomes, I'm going to fill those out. There's one $20 bill out of 10 total bills, so 1/10. There are two $10 bills out of 10, so 2/10. There are three $5 bills, so 3/10. And there are four $1 bills, so 4/10. And the way that we work this out is we do this where the expected value, the formula is we multiply outcome and probability. So we do that 4 times. So we're going to do 20 times 1/10 plus 10 times 2/10 plus 5 times 3/10 plus 1 times 4/10. Now here's the deal. I want you to do this in your calculator. It's going to be a lot easier. So I'm going to kind of jump over to the calculator. The way we do this is we're going to go ahead and clear the calculator. So second plus 7, 1, 2. And I'm going to go ahead and show the screen here. So what we do is we hit the stat button here. We're going to go to edit, and we're going to put our outcomes into L1. So our outcomes are 20, 10, 5, and 1. In L2, we're going to put in the probabilities. So 1 out of 10, 2 out of 10, 3 out of 10, 4 out of 10. And then what we need to do is we need to get the product of all of those. So what we do is arrow up here to the header row of L3. And we're going to hit the second button and then 1 to get L1 times second 2 to get L2. So what this is this is the product of all of these multiplications. And now what I need to do is I need to add all these up. Now I know you could probably add them up just looking at them, but I want to show you how you can do it in your calculator. You hit second, you hit mode. And what you're going to do is you're going to go to the catalog. Catalog is under the 0 button. So you do second, 0 for catalog. I say to hit the number 4 because that gets us to the T's. We arrow up twice, gets us to sum, hit enter. And we want to put L3 in here. So we do second 3. And when we hit enter, that tells me that my expected value here is going to be $5.90. So again, let me bring it back up. So my expected value is $5.90. So on average, I would expect to win $5.90 over a long period of time. So I know that's not one of the outcomes, but that's typically what happens with the expected value. That's typically what happens with expected value. So, okay, so that's the first one. I want to talk about the second one. Second one says, in a game, you flip a coin twice, record the number of heads that occur. You get 10 points for 2 heads, 0 points for 1 head, and 5 points for no heads. What's the expected value? Well, you have to think about what are the sample space here. When you flip a coin twice, you can get heads, heads. You can get heads, tails. You can get tails, tails, heads. You can get tails, tails. So there's 4 outcomes. So if you think about it, if you get 2 heads, you get 10 points. If you get 1 head, you get 0 points. And if you get 0 heads, you get 5 points. So those right there are my outcomes. Now what we need to do is figure out the probabilities of those. Well, the probabilities of those are, there's only one way to get 2 heads out of 4 total. There are 2 ways to get 1 head, so 2 out of 4, and 1 way to get 4 heads. So your expected value is 10 times 1/4 plus 0 times 2/4 plus 5 times 1/4. And you can quickly do the math on this one. When you do this, you're going to find out that the expected value is 3.75 points. Now, you could do this in the calculator. You get the same answer, but that's how you work the problem out. Okay, number 3. Number 3 says there's an equally likely chance a falling dart will land anywhere on the rug below. The following system is used to find number of points for players. So black is 40 points, gray is 20, and white is 0. So those are my outcomes. Black is 40. Gray is 20, white is 0. So those are my outcomes. And now I need to figure out the probabilities. Well, if we look at it, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's 15 possibilities. So all of these are going to be out of 15. Count how many ways there's black. 1, 2, 3, 4, 5, 6. 6 ways there's black. Count the ways there's gray. 1, 2, 3, 4, 5, 6. There's 6 ways there's gray. Count the ways there's white. There are only 3 ways to white. 1, 2, 3. So now again, expected value is outcome times probability. So 40 times 6/15 plus 20 times 6/15 plus 0 times 3/15. And I'm going to go ahead L1s for outcomes if you wanted to, L1s for outcomes, L2s for probabilities, multiply them together. And you're going to find out that your expected value, the number of points you should get on this one, is actually going to be 24 points. And so that's number 3. Now we'll do number 4. Again, number 4 says a mysterious card playing squirrel pictured above, card playing squirrel, offers you the opportunity to join his game. Here are the rules. You must pay him $2. You pay $2 to play. If you pick a spade from the shuffle pack, you win. So in this case, this is going to change a little bit on my outcomes, because in this case, I have 2 outcomes, really, if you think about it. I'm either going to win or I'm going to lose. Okay, so if I lose, let's start with lose. If I lose that $2, so I'm down $2. If I win, on the other hand, even though I get $9, I'm getting $9 back for $2 I've received. So 9 minus 2, I only end up actually making $7 because I get my original $2 back plus an additional 7. That's the 9 I get back. Now, if you pick a spade from a shuffled pack, if you remember from before, last unit, the way this works out, there are 13 spades out of 52 cards in a deck. That kind of simplifies to 1 out of 4 if you'd like. You can use it as 13 out of 52, either one works. So I'm going to go ahead and say 13 out of 52. And in this case, what we're going to look at is 39 out of 52 ways to lose. Your expected value is going to be a much shorter calculation. It's going to be -2 times 39 50-seconds plus 7 times 13 50-seconds. And again, you're going to go to your calculator on this one, and you're going to type it in. And so again, let's just do it just so we can actually see what it looks like in the calculator. So we're going to jump back to the calculator. We're going to do second plus 7, 1, 2. In this case, what we want to do is we want to go to stat. We want to go to edit. Our 2 outcomes are that we have -$2 or that we have plus $7. We put the probabilities in this row, so we're going to lose 39 out of 52 times. We're going to win 13 out of 52 times. We'll go ahead and multiply L1 times L2. So we're going to do second 1 times second 2, enter. And what's going to end up happening on this one is we're going to go ahead and we need to add those 2 together. So again, second quit to get back. Second 0 for catalog, 4 for sum, arrow up twice. Second 3. We're going to go, I'm sorry, we're going to do enter for sum, sorry, second 3, enter. And what that says is in this game that on average, I am going to make about 25 cents. So let me get back to their picture. So that says on average, I'm going to make 25 cents. So what this says is this is a game that I play because on average, I'm making money. I'm making money when I play this on average. So again, could I lose when I play the game? Sure. But in this case, when I look at it, I'm actually going to, on average, make a quarter every time I play this. Again, I know you're either going to lose 2 or win 9, but the average over the long run shows that there's a positive return on this. So this is some of those games that you'd want to play. So I'm going to do number 5, and then I'm going to pause, and we'll work on part of the backside in a different video, so it's not too long. Okay, a dice game involves rolling 2 dice. If you roll a 2, 3, 4, 10, 11, or 12, you win $5. If you roll 5, 6, 7, 8, or 9, you lose $5. Find the expected value. Okay, so first, I need you to know in terms of when you roll dice, how many ways. Because if you think about it, when I roll a die, 2 6-sided die, 2s, 3s, 4s, there's a probability. So the probability of getting a 2, there's only one way to do that. It's a 1 and a 1. And the way you figure out the sample space, again, remember, is you take the number of outcomes and you raise it to the number of trials. So in this case, there are 6 outcomes when I roll a die. There are 2 trials, 6 squared is 36. So it's 1 out of 36. The thing I need you to know, there's a good mirror image here. The probability of getting a 12 when I roll a 2-sided die, there's only one way to do that. 1 out of 36, it's a 6 and a 6. The probability of me getting a 3, it's a 1 and a 2 or a 2 and a 1. That's 2 out of 36. But that's also the same idea as the probability of getting a 11, which is going to be 2 out of 36, a 5 and 6, and a 6 and a 5. And there is that mirror image. So probability of getting a 4 is 3 out of 36. Really quickly, 36. 3 out of 36. The probability of getting a 10 is 3 out of 36. The probability of getting a 5 is 4 out of 36. The probability of getting a 9 is 4 out of 36. The probability of getting a 6 is 5 out of 36. The probability of getting an 8 is 5 out of 36. And the one all by himself, the probability of getting a 7, there's 6 ways out of 36 ways to get a 7. So that's all your probabilities. Now what we need to look at is we need to look at the game. And the game is dictated that if you get a 2, 3, 4. So again, this is going to be a longer one. My outcomes, if you think about it, in this case, my outcomes, my X's are going to be 1 out of 36. That's probability, sorry. Outcomes are going to be, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12. Those are my outcomes. So those are my X's. The probabilities are what I have above. In this case, I'm going to come back to this in a second because these technically aren't my outcomes. The dollar figures are my outcomes. I want to come back to that. There's a 1 out of 36, 2 out of 36, 3 out of 36, 4 out of 36, 5 out of 36, 6 out of 36, 7 out of 36, 5 out of 36, 4 out of 36, 3 out of 36, 2 out of 36, and 1 out of 36. Okay, so those right there are all my probabilities. Now, I want to pause because actually what I want to say is my outcomes are not the rolls. My outcomes are what happens with the dollar figures when I do those rolls. So on 2, 3, 4, 10, 11, and 12, I win 5. So in this case, technically, this is going to be a +5. This is going to be a +5. 4 is going to be a +5. 5 is going to be a no, 5 is going to be a -5. 5 is going to be a -5. 6 is going to be a -5. 7 is going to be a -5. 8 is going to be a -5. 9 is going to be a -5. 10 is going to be a +5. 11 is going to be a +5. And 12 is going to be a +5. So this is why calculator exists, because I need to put in all of those outcomes: 5, 5, 5, -5, -5, -5, -5, -5, -5, -5, 5, 5, 5. And what I need you to understand is in the calculator, it's going to do the heavy lifting. But the way you're going to work this out is you're going to tell me the expected value of this game. You're going to show me the first term, 5 times 1/36 plus ... And what I'm going to say is another 5 times 1/36. And when I do that in the calculator, what I'm going to find out is that the expected value here is that I'm going to lose $2.67. And if you look at it, it's more likely for me to lose, actually, if you add them up, 4, 5, 6, 4, 5, 6, 5. So again, these ones right here, 4, 5, 6, 5, 4. So 9, 15, 24, 28. There are 28 out of 36 ways to lose the game. There are 1, 2, 3, 6, 9, 11, 12. In this case, did some math at 9, 15, 23. Sorry. So we got 1, 2, 3, 6, 9, 11, 12. So there's 12 out of 36 ways to win. There's 24 out of 36 ways to lose. So what I want to go ahead on this one is I want to realize there's more likely that I'm going to lose than I'm going to win. So that's why my expected value is -267. So in the first game, I'd play that game because on average, I'm going to win. The second game, I wouldn't play the game because I'm expected to lose money over the long run. So that is kind of what expected value is. So that's the front side of it. I'm going to do some of the ones on the back just to kind of talk like specific ones, but it's just practice so that we understand what we're doing.